Electric field due to uniformly charged ring 2. Let us look at electric field due to ring at some special points. In order to get the electric field at center, substitute x equal to 0 in the general expression for field due to ring. Electric field at the center of the ring comes out to be 0. For points very near to the center of the ring on the axis, x is very small as compared to a. Thus, a square plus x square is approximately equal to a square, and the magnitude of the electric field is kqx by a cube. Hence, electric field at a point on the axis very near to the center of the ring is kqx by a cube and is directly proportional to its distance from the center. Suppose a charge minus q naught with mass m is left near the center of the ring. It would experience an attractive force. kq naught by a cube into x towards the center. Hence, its acceleration is directly proportional to its distance from the center. The charge would undergo simple harmonic motion about the center of the ring. The time period of the oscillation is equal to two pi root over ma cube by kq q naught. For points very far from the center of the ring on the axis, x is very large as compared to a. Thus, a square plus x square is approximately equal to x square, and the magnitude of the electric field is kq by x square. The result is the same as if the whole charge is kept at a distance x from the center. As expected, the electric field at a faraway point has no bearing on the shape of charge distribution at source and is inversely proportional to the square of its distance from the center. Let us identify the location of a point on the axis at which the electric field is maximum. We know that for small values of x, E increases with distance, and for large values of x, it decreases with distance. There must be a point on the axis of the ring where electric field is maximum. Let's say that point is x max, and magnitude of electric field at this point is E max. For calculation of E max, we have to solve for dE by dx equal to 0, which implies d by dx of kqx by a square plus x square whole to the power 3 by 2 is equal to 0, which upon solving gives us x is equal to plus or minus a by root 2. There are 2 points on either side of the ring at which the electric field is maximum, each at a distance of a by root 2 from the center. Maximum field on the axis will be given by substituting x with plus or minus a by root 2 in the expression for field. Hence, magnitude of maximum field is equal to 2 by 3 root 3 kq by a square. Thus, electric field due to a ring is maximum at a by root 2 from the center, and its magnitude is equal to 2 by 3 root 3 kq by a square. Summary: electric field at the center of the ring is 0. Electric field at points very near to the center of the ring on the axis can be approximated to kqx by a cube, and for points far away from the ring it can be approximated to kq by x square. Magnitude of maximum electric field due to a ring is equal to 2 by 3 root 3 kq by a square at a by root 2 from the center.